Hello everyone, welcome to the video chapter 11.4. In this video, we are going to talk about the preparations of amines. So there's four different methods to prepare different class of amine. First of it is reductions of nitrile compound to form an aromatic amine. So the reagents and conditions zinc, tin chloride, and iron in the presence of acidic conditions, and from this nitrile compound, it will form an aniline. Okay, the aromatic amines. Second method, reductions of nitrile compounds to form primary aliphatic amines. So from this nitrile compound or your cyano functional group reduce into a primary aliphatic amine. So this C triple bond N forms CH2NH2. So besides hydrogens in catalyst, we can also use the first step lithium aluminum hydride followed by water. Okay, there is a correction. So over here we are not using acidified water, it's just H2O. Okay, the reasons why we cannot use H3O plus is because this amine is a base. So it will react with the acid, so the product will not be the same anymore. So please remember, if you're using the lithium aluminum hydride, you need to use water in the second step. Or maybe you will use the sodium borohydride in the presence of methanol. Alright, the next method is the reductions of amides to form primary, secondary, or tertiary amines. Depends on what is the type of amide used. So in general, the C double bond O will be reduced into CH2. Okay, so recall that reductions, either you take away the oxygens or you put in extra hydrogen. So the reagents condition, first step, lithium aluminum hydride followed by water. Okay, again, the same thing, you cannot use H3O plus because this is a base and it will react with the acid. So we just maintain it as the water only without H plus. So the class of amine form depends on the type of amide used. If you have primary amide, you're going to form primary amine, secondary amide, secondary amine, and etc. So the next preparations of amine is this Hoffman's degradations of amides to form primary alkyl and Airy amines. So for this Hoffman degradations, we take off totally for this C double bond O from the amides. So if you look over here, initially there is a C double bond O here, and the product we're missing the CO group. Alright, so the reagents and conditions Br2 or Cl2 with a base NaOH in the presence of H2O. So for this Hoffman degradations, there is an elimination of carbonyl group, and we shorten the length of carbon change by 1 carbon. So if you're comparing between the reductions of amide using reducing agent and Hoffman degradation, both are from amides into amine. Amides into amine. But Hoffman degradations, it will reduce 1 carbon. So let's try the examples given. So reductions of nitrile compound in the presence of the reagents condition zinc, or you can use SnCl2 or Fe in the presence of acidic condition. So this NO2 will be reduced into amino. Okay, NO2 into NH2. So this is to prepare an aromatic amine. Second, reductions of nitrile compound. So looking at this CN, when it undergoes reductions, again, there's a corrections over here followed by water. Okay, and then this CN will then reduce to CH2 and H2. Okay, CN, the nitrile compound, reduced into a primary amine. And then the third examples here is the reductions of amide. So using the reducing agent. So for this amide, okay, number of carbon, you have 3 carbons here, and then this C double bond O will reduce into CH2. Okay, C double bond O reduce into CH2. And then for these structures, there will be corrections over here. We are using lithium aluminum hydride followed by water. So again, the same thing, reductions of amide using reducing agents. The C double bond O will be reduced into CH2. So if this is a skeletal structure, so you just remove the double bond O. And then lastly, so for this Hoffman degradations, you are going to reduce the length of carbon by 1 carbon. So for here, we still have 3 carbons at the amides here, and then this C double bond O we will totally take out from the amide, and then left only with 2 carbon. Okay, from 3 carbons into 2 carbon. And then for this amide as well, we're going to take away the CO and then forming an aniline. So total 7 carbons, and then over here it remains with 6 carbon. So that is the differences between the common reductions of amide and this Hoffman degradations.